everyone. Warm welcome to you. Thanks for joining this BCS Agile Methods Specialist Group event. This is our final event of 2023. So we're thrilled to be doing this, and we've got a really good agenda for you. Moving on to the main event, I would say. So I'm thrilled to welcome and invite Colleen Johnson to BCS Agile Methods. Colleen's a well-recognised name and face in the global community. She's somebody we've collaborated with. We've seen her speak at many other events. She was at Lean Agile London earlier this year as well, alongside myself, Ahmad, and others. And she's become a really good friend over the last few years as well. If you don't know, Colleen's I would say like a serial co-founder, CEO. So she founded Scatterspoke. She's a current CEO of Pro Kanban, and she's a transformational coach as well. So she's multi-talented, as you would expect. And I've heard Colleen speak a number of times, so I'm really thrilled she'd agreed to do this. And she's going to be helping share her perspective on predictability and supporting us in Agile, which is I think is always quite a fascinating and interesting topic. So without further ado, I'm going to hand over to Colleen. Thanks, Colleen. Welcome to BCS Agile Methods.
Thank you so much for having me. I'm also actually the co-founder of 3 kids, 5, 14 and 16 now. So that was my original endeavor into trying to build something. Let's see here. All right. Can you confirm we're seeing the right view, Seth? Okay, great. All right. So this is one of my favorite talks to give because it's a little different and a little controversial. And I'm excited to welcome you all into this conversation. I like to try to tee some things up here and then really open it up so we can really talk about what this means in your organizations, what you see. At any time, if you want to raise your hand, please do. We can pause and talk through some of these slides as we're going through it. We'll also have time at the end for more discussion. Today, we're going to be talking about getting predictable Agile delivery, which I feel like is often considered a little bit of a myth that it's even possible to have on-time delivery in Agile. This particular talk really was born out of a session we did with Pro Kanban early in 2023, where we got a lot of our trainer community together. And we started looking at the version 1 report, the State of Agile report that they put out every year. And in it, they survey a lot of companies about what methods are you using, how's your transformation going? And part of that survey was, what are the reasons that you are trying to adopt Agile in the first place? What brought you to want to be an Agile organization? And the number 2 reason was predictability. And I thought this was really interesting because I think what we hear a lot from an Agile perspective is that we can't be predictable with Agile, right? It's always evolving, it's always changing. And so this conversation and this talk was really born out of kind of a deep dive into, is it even possible to have predictable delivery with Agile? A little bit about Pro Kanban. Seth teed this up already. Pro Kanban was founded in October of 2020 by myself and Daniel Vacanti. We've grown over the last couple of years to have over 100 trainers in 12 different countries, or in 37 different countries, 12 different languages that we offer classes in right now. I'll talk a little bit at the end about some of our class offerings, but we try to make as much of our material free for learning as possible. So if you're interested in learning more about anything from Pro Kanban, you can check out prokanban.org and you'll see books, blogs, practice assessments, a lot of free materials there to continue on with your learning about what we're going to talk about today. So let's start very high level here. Seth and I were chatting at the beginning of this talk while we were waiting for others to join about some of the comments we saw on LinkedIn around predictability. And what do we mean by predictability from an Agile perspective? And I think this is a great place for us to start our conversation here. It's a debate I see quite a bit when we start talking about predictable delivery from an Agile perspective. What I mean when I talk about predictability is when and how much we're going to be able to deliver, not necessarily what we're going to deliver. So whether we're using Kanban or Scrum, we're working in a way where we're trying to get feedback quickly and fold that feedback into what we're going to deliver. So when I think of predictability, I'm not necessarily saying what we're going to deliver. I'm not trying to forecast to you what I'm going to deliver 6 months from now. In fact, I would, if I were coaching an organization trying to adopt those practices, I would push back hard on trying to build out roadmaps that predict what is going to be delivered. But what often happens, what's the first question when we start a new project or a new initiative, a new feature? What's the first question that we're going to be asked? When will it be done? When can I have it? Well, now we know what we want. When can I have it? So when I talk about predictability, that's what I'm thinking of. The reason I threw how much into the mix in addition to when is because if we're using models like Scrum or SAFe, there's often an element of planning that we're trying to do to determine how much can fit into a time box. And so predictability can also mean how much. And both of these models, whether we're talking about when you're going to get something or how much can be delivered by a certain time, are both about delivering on time, doing what we said we were, delivering what we said we were going to do. The what of what that is going to be is often evolving and hopefully evolving based on your customer feedback. So how do we typically do this? There are a handful of methods that I'm sure you've been exposed to in your careers in Agile that we often lean on to try to forecast when something's going to be delivered. Story points and velocity are a pretty common way we do this. Story points are based off the complexity that the team perceives the work is going to take, and they're comparative, right? So we're looking back at other work to say, how does this compare in complexity to these other work items that we've completed? Velocity is often another way that we're looking at how much work can we deliver by a certain time. So we're using often story points as a way to average out velocity over time and say, based on this team's past delivery, we can use this number of we can typically do this number of story points per sprint or per iteration. Burn down charts are also a method a lot of teams use, and that is a way for teams to say, based on a best case scenario and maybe upfront story point estimation, how are we trending towards delivering on time or towards getting all of these story points to done by the end of our time box? And some teams still base estimation off of working hours. I've seen a lot of teams that have either gone to some combination of story points and working hours, or basing their story points off of working hours, where they're really just saying, we're going to simplify down the story points available based off what we believe the scope to be, or the amount of time to be, to deliver this amount of work. So the first question I would ask is, are there any others too? Are there others here that I've missed that you've seen teams use? And feel free to come off mute or put it in the chat. It's dinner time there, huh? All right. So one of the things that's really interesting when we start thinking about a lot of these methods are that there's only one possible right answer. So what I would say about those methods is that instead of thinking through how many different ways could we see things go right or wrong, with all of those estimation methods, we've only got one right answer. So they're very deterministic in nature. When we start thinking about how we forecast, the other piece of this is it accurate, right? It's very hard to be accurate with our estimation methods when there's only one possible right answer. And we do this to ourselves, I think. I think we end up locking ourselves into a very specific number of story points or a very specific date on the calendar, because that's what we've always done. But what we want to shift our thinking to here is what we call probabilistic forecasting instead of deterministic estimates. When we think of probabilistic forecasting, think of the weather. So the weather gives you typically a range, a high and a low, and a probability. So they might say today's high is somewhere between 70 and 78 degrees Fahrenheit, and there is a 20% chance of afternoon rain. They do that because there's never going to be one exact result for the weather, right? We know we have enough information based on what we can model out here that we're going to come in somewhere in this range and this likelihood. So think about what that might look like as we start to think about dates. So if I were to come to your team and say, we have 25 user stories in this feature, when will it be done? What we want to shift our thinking to is saying, based on risk and probability, we can say that there is a 85% chance that we will deliver these stories somewhere between January 15th and January 30th. Because there's multiple different outcomes there, right? Now we have a range and a probability of hitting that date range. The other thing we can take from the weather is that forecasts get updated as new information comes in. So I might tell you that the weather today could be anywhere between 70 and 78 degrees and a 20% chance of rain. But as new modeling comes in to that forecast, or new information comes into that forecast, we go back and update it. And we might say, oh, now the high for tomorrow is going to be between 60 and 65 degrees Fahrenheit. We never seem to do this well with software or with Agile practices. Once we have that date, and I think that's why there's so much fear associated with giving dates. Once that date is set, it's often feels like a little bit of a death march to hit that date. What we want to do when we think about probabilistic forecasting is think about how can we update that forecast as new information comes in, and what things might be considered new information here. Things like the pace. So is our team slowing down or speeding up how much they're delivering? If our cycle time information is telling us that our speed that we're delivering at is increasing, we may have to slide out that range, right? Or pull it in if our cycle time is decreasing. So pace is one thing that we want to look at. Just scope is another part of deterministic or probabilistic forecasting, whereas we may add stories to a feature, or we may be looking at what things need to be removed or included. That story count may be changing, right? Or for our sprint, our story count may be changing. So we also want to think about how are we going to update our forecast as that new information comes in. And that means getting comfortable communicating that change. The last thing we can take from the weather is that a shorter forecast is always going to be more accurate than one that's farther out. I'm not sure, at least for the weather in the States, a lot of times you'll see a 10-day forecast and they don't go past 10 days. So if you look up things like weather.com, it might tell you, here's your 10-day forecast. And for the next day, if I look at the next 24 hours, it will give me an hour by hour forecast, but it won't go past 24 hours for that hour by hour. And then the further out I look, the more ambiguity there is in that information. That's because it's a smaller batch, right? So I have a smaller amount of information, a smaller range I'm trying to forecast, and I'm going to be comfortable with a higher degree of accuracy because I'm forecasting less. So how does this translate to work? This could be viewed in two different ways. So if we go back to that concept of either how much or when, how much in a shorter batch might be a sprint. So a 2-week sprint may be your smaller amount of time where you're saying, how much work can we get done in 2 weeks? Or when, if we have a fixed amount of scope, like a feature or an epic, making that feature or epic as small as possible is going to give you a higher degree of accuracy in your forecast. So I want to pause here and see if there's any questions on this concept of probabilistic forecasting versus deterministic estimates. All right. So let's talk about how we do this. How do we start to think about things from a probabilistic perspective? This is all great, but how do I get this information back? The way we start to shift to probabilistic forecasting is through flow metrics. If you Google flow metrics, you'll probably find a dozen different definitions of what flow metrics are. I'm going to use the definition from the Kanban guide. And there are 4 simple flow metrics: throughput, work in progress, work item age, and cycle time. And really, when we're starting to think about forecasting, the metric that you need here is throughput. chances are this is data you already have, right? So how much work do we finish for a given unit of time? You probably have throughput. If you're working on a Scrum team, you probably have throughput data based off of a sprint. Some tools will also give you a great view of throughput metrics at a daily rate. And a lot of times when we look at throughput from a daily perspective, it's not a whole number. So you might see in your tools, it might say your throughput rate is 0.46 items a day, which means it takes us 2 days to probably get 1 item to done. There's usually a strong correlation here between throughput and cycle time. And cycle time is how long does it take for an item to get completed. This is the elapsed time. So we include weekends here in cycle time. And the recommendation for why we want to include cycle time, or why we want to include weekends in cycle time, is because as a customer, as an end consumer, when I'm asking you when something's going to be done, I mean, when do I get it? I want to know the date that I get it in my hands. I don't want to try to figure out how many sprints or how many weekends or how many holidays are included in that. We just want to know when it's going to be completed. The other two flow metrics are work in progress and work item age. Now, when we talk about work item age or work in progress, if your team is using WIP limits, kudos, first of all. But when I'm talking about work in progress, I don't mean the sum of those WIP limits. So a lot of times when I ask a team, how much work is in progress, I see them add up the WIP limits at the top of their board. What I mean when I'm talking about work in progress is how much work is actually on your board. And what you'll find more often than not is there's a little bit of fluctuation there. My total WIP limits for my system, my work in progress limits, may sum up to 10, let's say, my team has agreed to. We're never going to have more than 10 items on the board. But day over day, maybe one day it's 9, and the next day it's 8 because we're waiting to pull in new work. And the day after that, it's 11. So we're going to start to see some variability in how much work is truly in the system, especially if we break those WIP limits, which is what I see a lot for teams. We might have a system WIP limit of 10, but our actual work in progress is like 14. So when we talk about WIP, when we're thinking about this from a flow metrics perspective, it means actual work in progress, not the sum of the WIP limits. And the last flow metric here, maybe the one that you've never heard of before, and that is work item age. So this is how much time has elapsed since I started on this item. This is for items that are still in progress. And this is really just telling us, how old is this? How old is this work? I say it's probably the most important flow metric you've never heard of because it's such a simple thing to start to make visible. And it's also, I think, a very sobering thing to make visible, especially when we start thinking about work as it scales up in our organization. So thinking about things like features or epics or whatever your scaling model looks like, starting to see how old those items are. It can get a little obscured, right? If you're carrying items over from sprint to sprint or PI to PI. But if you could go back and say, for all of our features currently in progress, how old are they from when they started to right now? If you had a feature that had been in progress for 200 days, you might have a different conversation about that item. Do we want to keep working on it? Is this work still valuable? Is it as valuable as it was when we started it over half a year ago? Is this feature still a high priority to finish? Maybe we just want to stop and deploy what we have now. Also thinking about things like, does the work need to be abandoned or backed out? It's not a conversation we have very often. I think we get very emotionally attached to any work that we start. So it's like once it's in the process, it has to finish, regardless of whether or not it's still valuable. So when we start to think about each of these flow metrics, we're going to use each one of these in a slightly different manner to help us drive predictability and understand when something will be done. So let's start with the dates first. How are we going to figure out our probabilistic forecast? We're going to do this through something called a Monte Carlo simulation. And when we think about a Monte Carlo simulation, really what it's doing is it's taking your team's historical throughput data. So how many items did your team get done each day for a given time period? And it's going to run this through a model. So it's basically just randomizing your data and trying it over a 10,000 instance period. This can be done in a spreadsheet, although it's a little messy, especially if you don't have a template for it. But there are a lot of tools you can use where you can plug in your historical throughput data, and it will spit out a Monte Carlo simulation of how that data, how that randomized data came out. Now, I mentioned there's typically two ways to run your Monte Carlo simulation. One would be to look at how much work can I get done by a specific date. The other one would be when will a certain number of items be completed. And like I said, to start this process to probabilistically forecast when something will be done, all you need is that throughput data. So let's take a look at what this looks like. So boss comes to Ahmad. Ahmad, we have a feature and it has 25 stories in it. Tell me when I'm going to have my feature back. So we're going to take this data here at the top that is telling us each day, each dot here at the top chart is how many items got done on a specific day. So starting here, you'll see there's a dot here for one item got completed. And then it looks like we had 3 days in a row where 3 items were completed. And then 2 days in a row where no items were completed. So you get the hang of this here. This is actual throughput data for this team. And these 2 dots together that you kind of see in patterns are likely our weekends, right? Or maybe a holiday weekend here where we had a longer weekend and no work was completed. So this is the data that I select to run through this Monte Carlo simulation. It's going to randomize that, like I said, and run it 10,000 times. And then it's going to model this here in this curve that tells us how many times each total throughput was delivered. And that's what gives us this curve here. So we're asking this particular model, tell me how many items I can get done in 20 days. Maybe that's the end of our sprint, is 20 days out. This is going to tell us, based on the randomization of this data, there is a 95% chance that you'll get 25 or more items completed. And you can see that here. It's a little hard to see the percentiles. You can see this percentile here is the 85th, going down to 70th, and then 50th. So if I was comfortable with the 50th percentile, which means there's a 50% chance I'll be wrong, I could increase the number of items I'd be potentially delivering. So there's a 50% chance I'll deliver 38 or more items. There's an 85% chance I'll deliver 29 or more items. So you can see the number of items is going down as my confidence is increasing. So when we start to think about how we might use this, right, now we can start to have a conversation about risk. And so I can start to say to stakeholders, how comfortable are we being wrong? Is 50% something we're comfortable with? It might be, depending on who your customers are and what your timelines look like. Is 95th percentile okay? Because that's gonna dramatically reduce the amount of work that we're going to commit to. And so you can start to see here, this model is helping us figure out how much risk are we willing to take on in our estimate. And I see a question here from Enrico. Between probabilistic and deterministic estimations, is one recommended over the other on an earlier or later stage of a rolling wave planning? Well, I'll give you thank you for the question. I'll give you my answer here. I think I would still do a probabilistic forecast, but the key here is what we call continuous reforecasting. And so you need to keep reforecasting this as new data is coming in to make sure your numbers are still on track. And that's where, depending on how your team works and how stable your team is and how they're delivering, that may change, right? So let's say I lost a person on my team this week and they were out and they, have a family emergency and they're not coming back. I'm probably going to see, if I were to reforecast this based off throughput data from the last couple of days with a team member out, that the number of items I could get done is going to start to go down. And so I would still lean on probabilistic forecasting regardless of where I was in the stages of planning, but I would keep reforecasting this each day, each week, and I'll show you an example of that here in a few minutes. Did that help, Enrico? Okay. All right, so how do we start to communicate this? We communicate this by telling us the likelihood, that 85th percentile is one I commonly use, and how long we think it's going to take for us to deliver that. There's another element here, though, when we start to think about how our team uses this, and this is cycle time. One of the things that cycle time can help us do is figure out how long does our work typically take. And so we use what's called a cycle time scatter plot. Unfortunately, the one in Jira doesn't do this for you. It will only give you average. There are some ways you can export this data into a spreadsheet and also figure out your different percentiles. But we want to start to think about, for all of our work, how long does it take for us to complete something? What's interesting about cycle time is we have a tendency to want to make that data look better than it probably is. I also see a pattern for a lot of teams where when we start looking at cycle time data, the team goes, there is no way it takes us that long to finish a story. Whether it's Scrum or Kanban, and very interestingly with a lot of Scrum teams I've worked with, we'll start looking at cycle time data and find out that 85% of our work takes 18 days or less. Well, what does that tell us? That maybe a lot of our work carries over from one sprint to the next. That's really hard for us to see if we're only looking at story points or velocity. So when we start to look at cycle time, it's going to tell us how long from when it starts to when it finishes does the majority of our work take. We want to be really careful here. Typically, you don't want to use averages on this because you'll be wrong about half the time. So if we're starting to look at how long does our work take us, why does this matter for predictability? Well, it matters because we want to start to manage this against our work item age. And we do that by creating what is called a service level expectation. The service level expectation is based on that cycle time data. So if we go back to that last slide, and I told you 85% of your work takes 14 days or less, your team is going to create a working agreement around that data point. So your team may say, if anything takes us longer than 14 days to complete, we're going to pause as a team, or anything is in progress for more than 14 days, we're going to pause as a team and figure out either how to swarm that work item, to split that work item, for example, or maybe we're going to decide to abandon that work item. But this is one of those things where once we start to forecast, our key to keeping that forecast accurate is to manage the work that's active. Cycle time's an important piece of this, but cycle time data is based off work that's already completed. So in order to do this effectively, we need to be able to see work item age. And so by making work item age visible, now we can start to have a conversation about really how old is too old for work in our system, and how do we start to keep that consistent over time so we're seeing less variability in that cycle time data. I see a question here from Ben. Is there a minimum sample size of throughput metrics you would need to feed into the Monte Carlo simulation to produce meaningful probabilities? That's a great question, Ben. So typically you need about 10 days worth of data, or 10 data points, depending on which way you're forecasting. So it could be 10 completed items or 10 days of throughput data. But what is important about the data is that you're trying to get the data you're using for your forecast to be like what you're going to be working on in the future. So what I mean by that is I might not pick throughput data from the Christmas holiday to try to forecast work that I'm going to be delivering in January or February. Or I might not want to pick throughput data from a project that was a brand new technology that people didn't really know if it's now something that the team is very well versed in. So you want to try to get your sample data to be like for like with what you're going to be working on in the future. That's not always easy to do, especially if it's a new team, like I said, new technology. And so in those cases, what I would come back to is that concept of continuously reforecasting and making sure that you have a starting point and that you're coming back to that data on a regular basis to say, now that more data is coming in, what are we learning about how we're delivering? Pratik Singh, who is a member of the Pro Kanban team, He talks about this a lot from the perspective of it's almost like machine learning. So the more your team delivers, the more accurate your forecasts will be because you have new data constantly coming in to that Monte Carlo simulation. And I'll show you an example of that in a moment. Did that help, Ben? Awesome. All right, so one of the things that becomes really important in forecasting is stability. I don't have a great picture of it in this deck, but one of the things we talk a lot about is what kind of things create instability in the work that you do. And a lot of times from an Agile perspective, when we talk stability, the first place our minds go is to team stability. And that's actually slightly different than what we're talking about when we talk about system stability. System stability really comes down to work in progress. And so I mentioned earlier, we may see our work in progress, our actual work in progress amounts jump up and down a little bit day to day. So maybe today it's 8, tomorrow it's 9, the next day it's 10, it goes up to 11, back down to 8. That is variability in our work in progress amount. But more often, if we're not managing that well as a team and keeping that consistent, what we start to see is that that number goes from 4 to 20 to 6 to 30, and that variability is very widespread. Well, what happens when our WIP is variable is that our cycle time and throughput becomes variable as well. And that variability makes it really hard to have high confidence in your outcomes. Pratik also has a great example of instability around Starbucks. And this is, I wish I had this picture here where he took a picture at a Starbucks he was at, and I think it was in like 2016 when they first introduced the ability to order Starbucks online. And what he said was he walked into the Starbucks, up on the counter, there were a whole bunch of cold drinks getting hot, hot drinks getting cold, and a line out the door of people. Well, what had happened is Starbucks introduced a new policy where if you ordered online, your drink got made first, ahead of all the people standing in the store. But what that created was an unstable process now where people are waiting in line for drinks. The bar is full of things that are aging because no one's there to pick them up, because they created an imbalance in the amount of work they had in progress. And so when we think about how this translates for our teams, it means keeping that amount of work in progress consistent over time is going to give us more consistency in our throughput and cycle time, and more confidence that we're not going to see that forecast jump around a lot. So as we're continuously reforecasting, we want to see that number stay pretty consistent over time. I think of all the things we've talked about, this takes the most discipline, right? Cycle time data is what it is. Understanding your cycle time data and having a working agreement around your SLE is a great conversation. Making work item age visible can be as simple as putting the date you start the ticket in front of the description in Jira or ADO so that you can see how old the ticket is. But managing your work in progress and keeping it consistent over time requires the discipline of the whole team. All right, so when we start to think about probability, we want to think about this from the perspective of risk tolerance. And I mentioned the downside of using averages is that when we're using an average, we're probably going to be wrong about half the time, unfortunately. And this can be especially risky for teams if what you see in your sprint data is that one sprint, let's say one sprint, and this is usually a symptom of carryover work. Let's say one sprint we get 10 points delivered, and the next sprint we get 50. And the next sprint we get 10, and the next sprint we get 50. We might average that out and say, oh, for this team, they average 30 points per sprint. But we're going to be wrong about half the time, every other sprint, about how much we're able to deliver, probably more than that. So what we want to think about when we're thinking about probability is how comfortable am I with the chance that I will be wrong? Or how many outliers can I tolerate? What I love about this concept is that this is a language a lot of our leadership speaks, right? They understand risk. And so what we want to think about here is how can we start to communicate with them based off of risk? So instead of saying, we'll have 30 story points done in the next sprint, if we could tell them there's a 15% chance we'll be wrong, but we believe that there's an 85% chance we'll deliver somewhere between 30 and 35 story points each sprint. Now we're starting to understand how likely we are to hitting that target. There's two different ways to think about this, right? We can manage risk or we can mitigate risk. We spend a lot of time, depending on the processes in your organization, we spend a lot of time trying to manage risk. And we want to try to think about this a little bit more around how we could mitigate it all, all together. When we think about the two differences here, managing risk often comes through things like process change and workflow policies. For example, I might say, in order to manage the risk of defects getting through to production, I am going to create a workflow policy that says that every ticket needs to go through 2 code reviews before it can move to QA. That's an example of how I'm trying to manage the risk. Mitigating risk are looking at how we can make changes to how we work so that we don't have to manage them. So thinking about things like we are going to do all of our testing in the dev environment before anything moves to a QA environment might be one way that we're trying to mitigate that risk of quality of defects making it into production. So as we start to think about managing and mitigating risk, what we want to make sure that we're doing is communicating that risk to stakeholders. And that happens by continuously reforecasting as that new data comes in. So things are unpredictable. And I know that was one of the topics in some of the comments on this thread early on about the talk is how can you be predictable with Agile delivery when pace changes, capacity changes, the scope changes, and it should change. What we're going to deliver should change based on customer feedback and what we're learning about what we deliver. But what we want to do with our forecast is be able to reflect that change. So what often happens? New scope comes in, our team slows down, it's the holidays. We go back to our stakeholders and we say, oh, I know we said we would be done with this on November 15th, but now it's going to be pushed to December 10th, right? I just gave you a deterministic outcome. I was wrong about my original forecast, and now there's only one new possible answer. I think it's kind of comical. We hate giving dates, yet our fallback when things change is always to set a brand new date. Instead of having a deterministic response to risk and change, what we want to do is talk about it from a likelihood perspective. And so if I had told you a couple months ago that there was an 85% chance we would deliver between August 1st and August 4th, new information comes in and I come back to you now and I say, okay, based on these changes, these 5 things have changed. Now there's a 56% chance we're going to hit that range. What did I do differently? I created an opportunity for conversation, right? Now we can mitigate or manage this risk. So instead of just changing the date and that being the only possible response, now we can have a conversation with stakeholders. Our likelihood is cut in half almost, or 30% less likely to hit that date range. But what are we going to do about it? We might say, okay, wait, let's pull scope out, or let's have a conversation now about how we could get that likelihood back up of still delivering inside that date range. If I just changed the date, I took that conversation off the table. There was only one possible outcome there. This is a fairly outdated view, but this was a tool that Pratik had built with a former customer of his, where it was running that Monte Carlo simulation, I think every 20 or 30 minutes against data for the team. And you can see here, it's telling you what the original code freeze date was for this particular team's work, how many stories they had remaining. And what's changing here and what you want your leaders to see is the likelihood. So in some of these cases, the ones that are in red, the likelihood is going down. Their stories are remaining. We're not looking at anything other than how much work is left and what's our likelihood of hitting this original code freeze date, or this 85th% completion date. So you can see the likelihood on these is going down. The ones in green are still high enough that we're probably going to hit that date. But the ones in red are the ones that we would want to have a conversation with about how can we start to manage that risk. You'll see there's some even down here that it's past the date. There's a 0% chance we're going to be able to hit that date. This is running that Monte Carlo simulation off stories remaining for each of these different lines. Like I said, I think it was either every 20 or 30 minutes. And so what's awesome about this is instead of continuously going back to your leaders and saying the date's going to change, the date's going to slip, what we can start to have a conversation about is for the items in red, what steps do we need to take to try to mitigate or manage that risk? I want to pause here and see if there's any questions on this concept.
Nothing in the chat. No hands up.
Okay. Awesome.
Okay.
Great. Yeah, and I think, over the course of my career, I've worked with so many teams and in so many organizations where everyone's afraid to give a date. No one wants to put a date out there because they don't want to be held to something unrealistic. And I think in so many cases, we do that to ourselves. And this is a great stepping stone to try to chip away at building more trust with how we communicate to our stakeholders. The other piece of this is, are we getting better, right? And so all of these practices can help you start to forecast, but what we also want to look at are we improving how we're delivering? Cycle time and throughput metrics are, we talked about work item age and work in progress. Those are the levers you have to pull. That's work that isn't delivered yet. That's work that's still in progress. And so if I can see that something has aged past a reasonable amount of time, I can take action on that. If I can see my WIP limits or my actual work in progress amounts are going up or jumping around a lot for a team, I can take action on that. Those are real-time metrics. Cycle time and throughput are work that's already completed. And while cycle time can help you determine your SLE and your working agreements, and throughput can help you run these Monte Carlo simulations, looking at them over time is a great tool for retrospectives. So I would highly recommend those two metrics as a starting point for retrospective conversation and looking at what kind of changes do we want to make to our process to help us manage and mitigate risk earlier in how we're delivering. So the awesome part about all of this, you have all this data. Chances are you have all this data. Jira makes it a little clunky to export it cleanly, but you can get a lot of this and even be able to look at, all you need is start date and end date for each ticket, and that will give you your cycle time data. One important note, if you're doing this in an Excel spreadsheet, you'll want to add 1 day on your cycle time calculation, because if I start an item today and I finish it today, that's a cycle time of 1 day, not 0. So if you're doing end date minus start date, you always want to add 1 if you're calculating that manually. What's important about using data you already have instead of estimating is that it includes all these things that are really hard to account for. If I were to ask you, how long will it take you to paint your bathroom? You might tell me, my bathroom's very small. 1 wall's a shower, 1 wall's a door. I can have that done in 2 days. And I say, great, staff, go paint the bathroom. And you get in there and you have to take the medicine cabinet down and tape all these tiny corners around the tub. And then you get a coat of paint up and it's wet in there and humid. So you have to wait 2 days for it to dry and then do another coat and then wait 2 days for that to dry. And a week later, I'm like, why don't I have my bathroom back, right? When I ask a team to estimate, they're not trying to give bad estimates or sandbag those estimates. They're often just thinking about their time, hands on keyboard, how long will this take me? It's really hard for us to include things like variability, unplanned work, and wait time when we're estimating, because we're only thinking about how long am I rolling the paint roller, right? When we use past data, we get things like variability, meeting, sick time, vacation time. We get unplanned work that's already reflected in that data because that's the reality for our team. So if I were to say, how often does it typically take to paint a bathroom? Well, it looks like most bathrooms, based on our data, take 7 days or more. To be 85% takes 7 days or more. Now I have actual data that's inclusive of all those things that were hard to account for. So start with data you already have and try not to guess at these things. You probably have a lot more data than you think for teams. And even if you're looking across the organization at data, that can be a great place to start as well. I see a question here from Tom. Do you have any methods for predicting time to deliver changes in qualities, like 60% security in the past, 99% security level in the future? I guess it would be more based, it's more like this rolling chart view where you would just be changing that likelihood over time, if I understand the question correctly. So I might forecast at a given point in time, like that there are 12 stories from when we started. Now, like at the beginning, I had a 85% likelihood of delivering. If I were reforecasting that every day, I might see that number change based on the confidence level and things changing for the team, like pace, scope, or throughput. Am I answering that? I'm not sure if I'm understanding that question correctly. Tom, feel free to come off if that's easier.
Okay, no, that's fine. Thank you.
Yeah, and you had another one here. Do you have any methods that are based on redesign to improve cost or time? Honestly, managing the amount of work in progress is probably the best method to start to manage that. So limiting your WIP and as a team saying we're going to work on less is a really powerful way to start to see improvements to how much things cost or how long they're taking. But making the work item age visible is a great way to drive that conversation. One of my colleagues at ProKanban was working with an organization. It was a physical board, so pre-COVID, I think, but they were trying to bring some visibility into features that were aging unnecessarily. And so it was around US Thanksgiving time, and he had brought in a pack of turkey stickers. And so they would put a turkey sticker on the feature every time another month had passed that it had been in progress. Well, long past Thanksgiving, this practice stuck around and they started referring to the features that took more than 6 months as the turkeys because they were covered in these stickers. And when you start to see that, that's a really powerful motivator in addressing it, right? And so instead of, if you think of those flow metrics, instead of thinking about, hey, it looks like all of our features are taking us 8 months to complete. Seeing that data real time and being able to take action on it is really what becomes important. So I would say making your work in progress and your work item age visible are the best steps to start to improve cost and cycle time.
Thank you.
Yeah. All right, so start with data you already have. You probably have more than you think. And that is all the content I have for you. I know that's a lot in a very short amount of time. Like I said, if you want to check out any more of our learnings or offerings for prokanban.org, we have a bunch of public-facing courses around this content. A lot of what we've talked about here are concepts that are included in our Applying Metrics for Predictability course. It's a 2-day course with an optional assessment, a certification assessment at the end of that. And I highly recommend the Flow Metrics for Scrum Teams book from Dan Vacanti and Will Seeley if you're looking for how to incorporate a lot of these concepts with your Scrum teams.